Welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Arbat College, University of Delhi. So presently, as you all are aware that we are going through our series of operating system concepts, and the topic which we are studying presently is about disk scheduling algorithms, and we have already seen one of the disk scheduling algorithms which was the simplest one, and that was first come first serve disk scheduling algorithm. So first come first serve, let's have a quick recap of this first come first serve, and then we'll quickly move on to our today's agenda of other disk scheduling algorithms. So in first come first serve, as the as and when the request comes up, these requests for the access of disk are we can say inserted in a queue, and they will be taken from the queue, and as we are talking about queue, it is first in first out. So whichever request is coming first will be served first. But what is the problem with that particular scheduling algorithm is that it does not try to optimize the seek time, and then let's say there is a request from there is a request for, let's say, cylinder number the sector number 37, and then it may go up to 214, and then it may come up to sector number 47. So this is kind of wild movement as and when your requests are coming up. So it is that algorithm is not having any provision to optimize the seek time, and just because of this it may not be able to provide the best possible service. But the advantage with the first come first service, every request gets a fair chance, and there is no indefinite postponements, and this is the most simplest one to we can say implementation. Now coming to the next one, which is SSTF, which is shortest seek time first. SSTF as in shortest seek time first scheduling. The idea here is to service all the requests which are close to the current hash position. That means seek time is we can say looked for, and this seek time whichever request is having the shortest seek time will be given the first priority. Now before moving the head far away for other requests, it is it is looked in the proximity of the current head position, and it will all the requests which are in proximity will be serviced first, and the assumption is this assumption is the basis for shortest seek time first algorithm. Now the shortest seek time first algorithm can be compared with our SS shortest job first algorithm in CPU scheduling. So whatever the criteria was the shortest job first algorithm in CPU scheduling, the similar criteria here is followed for SSTF algorithm. Now the SSTF algorithm operates in such a way that it selects the request with the least seek time from the current head position, or we can also say that it chooses the pending request which is closest to the current head position. Now let us take an example and compare this shortest seek time first. Let us try to understand this first, and then we will compare it with the previous one, which is the first come first serve, which we have already studied. Now we are taking the similar example of this thing. The reference string is 98, 183, 37, 122, then 14, 124 and 65 and 67, and let's say the current this current head position is 53. This is the similar example which we have taken for shortest first come first serve. So in shortest seek time first from 63, it is going to look for all the we can say request. The closest one is 65. After 65, the closest one will be 67. Then 37 is going to give the least or the shortest seek time. Then it should go to 14, then to 98, and then 120, and then 124. Now if we can see earlier in our first come first serve, the total had movement was something 600 plus. Now here if we can say the if we can see the total head movement, it is only 236 cylinder, which is kind of little more than 1/3 of the distance needed for the FCFS scheduling of this particular request queue. So the idea behind taking the similar example is we will be able to compare the policies, we will be able to compare the algorithms quickly. So if we are able to reduce down or seek or the total head movement total head movement by a factor of 2/3, then we can say it's a substantial improvement in the performance. So let us try to see this pictorially. We have shortest seek time first scheduling, and the reference string or the queue of the request is looking for the request which is going to be served at number 98, then 183, 37 and so on and so forth. So head starts from 53, it will go to 65, then it will go to 67, then it will go to 37, 14, then 98, 122, 124 and then 183. So this is going to be the actual we can say the graph of the head movement which is being shown here on the screen. So this can be compared with the head movement graph of the first come first serve FCFS scheduling, which was kind of having too many jumps from one side to another side, and those jumps were actually quite large, and we can say they were also wild. Let's say for example, it go from 53 it goes to 183, and from 183 it may sometime it will come to 37. So from 98 it will go to 133, and from 183 altogether it will come to 37. So that's a kind of we can say a very weird jump, and it is going to increase the seek time. But here in this shortest seek time first, the seek time or the cylinder head the head movement is going to be optimized, because we will be looking for the proximity request first, that will be served first, and the requests which are far away from the current head position will be served later on. Now coming to what are the advantages and disadvantages of this particular scheme or this particular disk scheduling algorithm. Advantages, we can say average response time, definitely it is going to decrease. Earlier it was kind of we can say very huge, but now that response time is improved, we can say. Then also there is an increase in throughput because the response time is improving. So within that particular time, or let's say time threshold t, it will it will serve more number of requests. So obviously the throughput is going to be increased. Now coming to the disadvantages, what are the disadvantages of this particular algorithm is, one thing is there, because the or the head is moving according to the shortest seek time, that shortest seek time has to be calculated. So for example, let's say the current head position is 53, then it has to be checked what all are the requested requests which are close to 53, which one of them is to be fulfilled, which is having the least seek time. So there is clearly an overhead to calculate this seek time in advance. And also, as we have seen in our shortest job first algorithm in CPU scheduling, this may that may lead to starvation. Similarly, here also this may lead to starvation for a particular request if it has a higher seek time as compared to the incoming request. So for example, let's say a request is having a higher seek time of maybe let's say some let's talk about this in terms of cylindrical movement, head movements. So let's say some 130 cylinders have to be 130 sectors have to be moved on. Now coming to the incoming requests are coming, the new incoming requests which are keep on coming in the systems are having less this less movement requirement, then this one which is having a higher seek time may go into the state of starvation, and also there is high variance of the response time, as shortest seek time first favors only some requests. So, response time could be very different. So, for one particular it is going to be, let us say some 2 units, and for another request it could be let us say 150 units, because it is going to the scheduling algorithm is favoring some requests which are having the lesser seek time. So, there could be a very high variance of the response times also. Now, after the shortest seek time first, let us move on to the next one, which is the scan scheduling algorithm. So, the scan scheduling algorithm basically works on the agenda that the disk arm moves in a particular direction and services the request coming in its path, and after reaching to the end of the disk it reverses the direction and then again services the request arriving in path. That means it is going to take one particular direction, will service all the requests coming into that coming into its path, and then reaching towards one end of the disk axis thing, it will reverse back its direction and service the request arriving in its path. So, this algorithm is very we can say simpler to the algorithm on which an elevator or a lift in a building is going to is implemented. So, for example, let us say we have started from ground floor and we want to go to the floor number 30th. So, as and when the requests are coming, your elevator or your lifts stop. That means its request, its it fulfill the request, it fulfill all the request coming along its way, and then while coming down it will do the same thing. So, this algorithm on which your scan scheduling technique works is also known as elevator algorithm. As a result, what is happening here is the request at the mid range are serviced more, and those arriving behind the disk arm will have to wait. So, for example, the lift has just moved on to 5th floor. So, whatever request is coming from the, let us say, 3rd or the 4th floor, those requests will have to wait maybe a little longer obviously. Now, let us say we will be taking the similar reference string which we have taken for our earlier 2 examples of your this thing first come first serve and shortest seek time first. So, here again the reference string is 98, 183, 37, 122, 14, 124, 65 and 67. So, the similar example we will be taking in order to understand this scan algorithm. But as I have already told you that the direction of the head movement is important. That means we need to know the direction of the head movement along with the current head position. So, the current head position is, let us say, 53, that is fine, but whether your head is moving in the right direction or the head is moving in the left direction, that also has to be, that is also a factor which has to be determined. Then let us say, for example, here with this we assume that the current position is at 53 and the disk arm is moving towards 0. So, the and the initial head position is 53. So, the head will service the request which is at 37 and then which is at we can say 14. So, here if we can see in this figure, so 53 was the current position which we have from which we have begun, and then the direction of the head is towards, we can say, left. So, as in it is going towards the number 0. So, from 53 it will service 37, then it will service 14, and then after servicing 14 it will go till 0, because that is what your scheduling algorithm says. It will go towards 0. Now, in between 0 and 15 there was no request to be served, and then it will change the direction, and when the direction has been changed it will start then it will go for 65, then it will go for 67, then 98, then 122, 124, and then 183. So this is going to be the sequence in which your requests, we can say, are being fulfilled. So at cylinder 0, the arm will reverse and it will move towards the other end of the disc, while servicing the request number 65, 67, 98, 122, 124 and 133. Now what is happening? If a request arrives in the queue just in the front of head, it will be serviced almost immediately, and on the other hand, a request arriving just behind the head will have to wait until maybe for a complete cycle, until the arm moves to the end of the disc, reverse directions and come back. So in elevator this also happens. For example, the elevator is at fifth floor. Immediately a request from the 7th one comes up, it will be taken up immediately, while the request which is coming from the 4th floor, because the elevator has already passed the 4th floor, then this request of 4th floor will be taken up when the elevator will complete one round till, let us say, 30th floor, and then it will come back. So while coming back, it will be taken up. So similarly here, a request arriving just behind the head will have to wait until the arm moves to the end of the disc, reverse the direction and then come back. Now let us try to see what are the advantages and what are the disadvantages of this particular algorithm. So we can say advantages, it is going to give you a high throughput. Also the disadvantage of shortest seek time first, which was a high variance of the response time, will be taken care in this. This is going to give you a low variance of the response time, and the average response time is also kind of, we can say, improved. So in advantages we can say there is a high throughput, average response time is improved, and the variance of the response time is quite low, obviously, as compared to shortest seek time first. Now coming to the disadvantages, we can have, there is long waiting time for the request for the location just visited by the disk arm, as we have taken the example of 5th floor, the lift at the 5th floor and the request is coming from the 4th floor and the elevator is presently going up. So for this type of situation, there is going to be, we can say, a long waiting time. Now coming to our next algorithm. So in this lecture till this point, we have seen two algorithms, which is shortest seek time first and the scan. Now coming to the next one, which is more commonly known as C-scan. C stands here for circular. So this is circular scan. It is, as the name indicates, it is a variant of scan which is designed for, we can say, improvement. It is designed to provide uniform wait time. Now for example, like scan, how does this C-scan is implemented, or how does this C-scan is taking place? So like scan, our C-scan also moves the head from one end of the disc to the other, servicing all the requests along the way. But when the head reaches the other end, it immediately returns to the beginning of the disc without servicing any requests on the return trip. Here is the difference, which says when the head reaches the other end, it immediately returns to the beginning of the disc without servicing any request on the return trip. The C-scan or the circular scan scheduling algorithm essentially treats the cylinders as a circular list that wraps around from the final cylinder to the first one. Now we can say, let us try to see what are the how it is going to be implemented, and then we will see advantages and disadvantages. So with the similar reference string of 98, 123, 183 and so on and so forth, head starts at 53. This is the similar example which we have taken earlier. Now our current position is at 53 and your disk head movement is towards the we can say right direction. It is not towards the 0, but it is in the opposite direction. So it is going from 53 to 65, 65 to 67. So from 53 it will traverse towards the end, which is 119, and then what is happening here, it is going to service all the requests which is coming in the way. So from 53 it comes to 65, then 67, 98, 122, 124, then 183. Now it will go to 199. Now this is of 200 cylinders, so this is going to come to an end. And meanwhile, while coming back, it is not going to serve any of the request here. So from 199 you can see no request is being served, there is no we can say segmentation of the line. So from 199 it will come to the 0 straight away without servicing any request, and then it will start the round again, and then it will we can say serve the request at 14 and at 37. So this is what your C-scan scheduling is, that the requests are being serviced only in one particular direction, either from either in the left direction or from the right direction. Now one must be wondering, then what is the advantages, what are the advantages and disadvantages of this this scheduling algorithm, in which we are altogether kind of sidelining the service request or in one particular direction. So here we can say the wait time is uniformly distributed among the requests. So in scan you have seen the wait time is having is varying a lot between the request, but here the waiting time is uniformly distributed among all the requests, and the response time here also is, we can say, reasonably good. But the disadvantages is the time taken by the disk arm to locate a spot is going to be increased here, and the head keeps going to the end of the disk, while in the previous one it was not there. So the head here keeps going to the end of the disk, and the time taken by the disk arm to locate a spot is increased here. So yes, it is going to give you a uniform waiting time, also a reasonably good response time, but it also comes with certain disadvantages. Now in this you can see that there is something that disk arm is going to the end of the end of the disk, irrespective of whether any service request is available there, yes or no. So let's try to improve this. So for example, in our previous setting, let's say we have our last request on the right hand side to be served as 183. Then if it is at 183, there is no point in taking the head to be moved to 119, that means towards the to the end of the disk. So another scheduling algorithm comes up, which is named as look. It is similar to the scan, except that the disk arm, in spite of going to the end of the disk as it was done in scan, goes only to the last request to be serviced, which is in front of the head, and then it reverses the direction from there only. So for example, if you can see here, 183 was the last request which is to be served, but your head went up to 199 because that was the last cylinder. Now there is no point in going to 199 if there is no request from if there is no request lying between 183 and 299. So that point has been we can say taken care in case of look, that in spite of going to the end of the disk, the head will go only till the last request to be serviced, and from there it is going to reverse its direction. So basically what it is going to do, it is going to prevent the extra delay which occurred due to unnecessary travel to the end of the disk. Also, we have seen what the advantages which are available with scan will obviously be available with look, but apart from that, one more advantage which comes with the look scheduling algorithm is, as the head is not going to the end of the disk time is not wasted here, starvation does not occur, and all other advantages which are available with scan are also available here with look. And the disadvantage is, the arm has to be cautious enough to find the last request. That means there is some amount of processing, or some amount of kind of flagging required in order to stop the disk arm till the last request, because now the disk arm does not need to go through does not need to go till the last of the last end of the disk. As we have seen the two versions of scan, one is scan and another one is a C-scan. Here also we have the circular look algorithm, which is the variant of look, similar as the look algorithm. The only difference is that after reaching the end request, it reverses the direction and it starts moving to the initial position. While moving back, it is not going to serve any request. So till this point we have seen many disk scheduling algorithm which are commonly which are commonly available, which are first come, namely first come first serve, shortest seek time first. Then we have seen scan, a variant of scan as C-scan, then look and C-look. Now the question which immediately comes up to the mind, that which is the best one. So although there is no such policy which gives you a hard answer for this, but reasonably we can say that yes, shortest seek time first or look are the good choices to be the default algorithm. So being as default algorithm, either the operating system are going to choose for, operating system designers are going to choose for shortest seek time first, or it could be look, because both are kind of reasonably sensible choices for a default algorithm. So with this disk scheduling algorithm topic is completed. So we have seen many of them along with the advantages and disadvantages. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed it. I'll see you in the next lecture. Till then, goodbye, take care.